everyone, and welcome. We have just landed to our new discussion. And for today's video, we're going to touch down mathematical language and symbols. This video have three objectives, and those are discuss the language, symbols, and conversions of mathematics. Second, explain the nature of mathematics as a language. And third, appreciate that mathematics is a useful language. This concept map presented is our title or the main topic, which is the language and symbols, followed by its subtopic and its reporter. First, introduction, in which I am doing right now, and then discussing the language, symbols, syntax, and rules of mathematics, who will be discussed by yours truly, Rexer Padihinog. Second, writing mathematical language as an expression or a sentence, that would be discussed by Miss Paula J. Ortiz. Next is example of writing mathematical language as expression or sentence will be discussed by Miss Charity Montefolca. Mathematical conversion by Miss Rose Ankima. Fifth, perform operations on mathematical expressions correctly by Miss Desiree Mingito. And lastly, example of perform operations on mathematical expressions correctly and to be discussed by Miss Debbie Princess Obian. Syntax and rules of mathematics. The language of mathematics is the system used by mathematicians to communicate mathematical ideas among themselves. Mathematics is a language, or as a language, has symbols to express a formula or to represent a constant. It has syntax to make the expression well-formed, to make the characters and symbols clear and valid that do not violate the rules. Mathematical symbols can designate numbers, which is what we call constants, variables, operations, functions, brackets, punctuations, and grouping to help determine order of operations, and other aspects of logical syntax. A mathematical concept is independent of the symbol chosen to represent it. In short, convention dictates the meaning. The language of mathematics, according to Wikipedia, makes it easy to express the kinds of symbols, syntax, and rules that mathematicians like to do and characterized by the following. First, precise, able to make very fine distinctions. Example, the use of mathematical symbol is only done based on its meaning and purpose, like the plus sign means add, minus sign means subtract, the x sign means multiply, and this sign means divide. B. Concise. Able to say things briefly. Example, the long English sentence can be shortened using mathematical symbols. 8 plus 2 equals 10, which means 8 plus 2 equals 10. C, or the third one, is powerful. Able to express complex thoughts with relative ease. Example, the application of critical thinking and problem-solving skills requires the comprehension, analysis, and reasoning to obtain the correct solution.
Good day everyone, my name is Paula J. Ortiz and I'm going to discuss about the writing mathematical language as an expression or a sentence. So, an expression or mathematical expression is a finite expression of symbols that is well formed according to rules that depend on the context. It is a correct arrangement of mathematical symbols used to represent a mathematical object of interest. An expression does not state a complete thought. It doesn't make sense to ask if an expression is true or false. The most common expression types are numbers, sets, and functions. Numbers have a lot of different names. For example, 5, 2 plus 3, and 10 half. All look different but just a different name for the same number. This simple idea that numbers have a lot of different names is extremely important in mathematics. The basic syntax for entering mathematical formulas or expressions in the system enables you to quickly enter expressions using 2D notation. On the other hand, a mathematical sentence is an analog of an English sentence. It is a correct arrangement of mathematical symbols that states a complete thought. Sentences have verbs. In the mathematical sentence, 3 plus 4 equals 7. The verb of that mathematical sentence is the equals. A sentence can be always true always false, or sometimes false. For example, the sentence 1 plus 2 equals 3 is true, while the 1 plus 2 equals 4 is false. So that's all. Thank you.
Now that we have an idea of what a mathematical expression or mathematical sentence is, I will give you more knowledge and examples so that you can better understand the topic. In simple words, mathematical expression does not state a complete thought. It does not make sense to ask if an expression is true or false. While mathematical sentence has a correct arrangement of mathematical symbols that states a complete thought. Now example of an expression is x plus 19. So you will add the value of x to number 19. And then what? We cannot determine what's next. The thought is incomplete. Same with x divided by 4. So what if we divide x by 4? What's next? What's the point, or what do we expect to happen here? As you can see, an expression does not contain an equal signs and cannot be solved. Next is mathematical sentence. For example, by the way, a sentence can be always true, always false, or sometimes true or sometimes false. For example, the sentence 2 plus 5 equals 7. So this is true since it has the correct answer. Another one is 3 plus 7 equals 9. Now we can say that this is false because of its wrong answer.
Mathematical convention. A mathematical convention is a fact, name, notation, or usage which is generally agreed upon by mathematicians. For instance, the fact that one evaluates multiplication before addition in the expression 2 plus 3 times 4 is merely conventional. There is nothing inherently significant about the order of operation. Mathematicians abide by conventions to allow other mathematicians to understand what they write without constantly having to redefine basic terms. Nearly all mathematical names and symbols are conventional. The longer a name or notation has been in use, the more likely it is to become a mathematical convention. Unfortunately, some notational questions stubbornly refuse to develop conventionally solutions, usually because two or more competing conventions achieves widespread usage.
Perform operations and mathematical expressions correctly. The following order of operations is a critical point to remember when simplifying mathematical expressions. Order of operations is the structure of mathematical operations. It's a collection of guidelines that defines which operation should be performed first or last. The MDAS, which stands for multiplication, division, addition, and subtraction, was previously used. PEMDAS stands for parentheses, exponents, multiplication, and division, as well as addition and subtraction. Most scientific calculators now use BODMAS, which stands for brackets, order, division, multiplication, addition, and subtraction. BODMAS or PEMDAS, or the order of operations, is simply a collection of rules that prioritize the sequence of actions from most important to least important. Step 1. First, simplify everything inside the parentheses as much as possible. Step 2. In the numerical statement, simplify every exponential number. Step 3. From left to right, multiply and divide whatever comes first. And step 4. Add and subtract whichever comes first from left to right.
In perform operations and mathematical expression correctly, we will use PEMDAS. The order of operations is a rule that tells the correct sequence of steps for evaluating a math expression. We can remember the order using PEMDAS, parentheses, exponents, multiplication, and division, addition and subtraction. Here is an example. 12 divided by 2 plus 12 divided by 2 times 3. Using the PEMDAS rule, we need to evaluate the division and multiplication before subtraction and addition. It is recommended that you put in parentheses to remind yourself the order of operation. From the given 12 divided by 2 plus 12 divided by 2 times 3. So 12 divided by 2, we must put that in a closed parentheses, plus that 12 divided by 2 times 3 are also put in a closed parentheses. Next, we divide the 12 divided by 2 is equals to 6. Next is that 12 divided by 2 is 6 times 3, it equals to 18. Next is we must add the 6 plus 18 and it equals to 24. So that's the example, and perform operations on mathematical expressions correctly using PEMDAS. That's all. Thank you.